Hello and welcome to all in this video lectures series on 8051 microcontroller. From some previous lecture session, we are discussing the timer section which is present in 8051 microcontroller. Till today, we had discussed the structure of timer block in 8051 microcontroller, the different SFR, that is TMOD, TCON registers associated with the timer, and the different mode of operations for timer. So in today's session, we are going to discuss the timer mode 1 operation using assembly language programming. So let's start. So as we know that in case of 8051 microcontroller, total 2 timers are there with us. The first one is called as a timer 0 and second one is called as a timer 1. And to have the control over these two, we are there with two SFRs, I can say. The one is TMOD, that is timer mode selection register, which is 8-bit file, and the second one is a TCON. Okay, so that is timer control register. The TMOD mainly used to configure the timer block either as timer or counter, as well as it is used to set the mode of operation. Okay, that is whether mode 0, mode 1, mode 2 or mode 3, right? Whereas the TCON register is used to turn on or off the timer. This activity is done with the help of TR bit, which is present in this TCON register, and the second one, it carry the flag. Okay, so that is nothing but a timer flag which mainly deals with rollover or going to indicate the overflow of time. Okay, so this is little bit about the revision about the basic timer section which is present in 8051 microcontroller. So whenever I am going to deal with this timer programming, I am going to make use of either timer 0 or timer 1 along with TMOD and TCON register. Okay, so here in this video session we are going to discuss the 16-bit mode, that is a mode 1 configuration or the programming or operation for 8051 microcontroller. Okay, so as we know that in 16-bit that timer mode, that is in mode 1, what we are going to do, we are going to make use of all 16 bits of timer, and as per our use we can use either timer 0 or timer 1 for operation. Okay, so these are the some basic preliminary steps that we have to follow while doing the timer programming. Okay, so whenever I want to program the timer in mode 1, what I am supposed to do, these are the 6 what we call the fixed steps that we have to follow, right? So the timer programming is nothing but what, as per these steps, simple, I am going to write the program there. Okay, so what is the first step? Load the TMOD register with suitable value. Okay, so what that value indicate? It indicate whether to use timer 0 or timer 1, the mode of operation, right? So exclusively as we are dealing with mode 1, we have to write an instruction so that the mode 1 is selected and configure timer as timer or counter. Okay, means what? Suppose it is likely to be used the timer 0, okay, in mode 1 as timer. Just try to get this. In my program statement, it is mentioned that use timer 0 in mode 1 as timer, right? So what we are supposed to do, when I am going to talk about the TMOD register, the first bit is gate, then C/T bar, then again M1, M0, right? And again the same replications, gate, C/T bar, M1 and M0, right? And as we had just now considered, we have to depend or we have to use the timer 0 for operation, and for that purpose the upper 4 bit which are associated with the timer 1 I am going to keep as a 0. Right. Now the gate bit we are not going to use. The timer is supposed to be used into the timer, so the status of c/t bar is 0, and for mode 1 the m1 and m0 status is a 1 0. So what will be there? To indicate these all, as per the program statement, I am supposed to write an instruction move tmod comma hash simple, sorry, this is a mode 1, so for mode 1 it is 1 0. Okay, extremely sorry for this, as we have to select the mode 1 of operation, right? So for that the value will be what? It is a m1 is 0 and m0 is 5. Okay, so this value is what? Move tmod comma hash 01h, right? So when I am going to write this instruction move tmod comma hash 01h, what will happen? The timer 0 is configured in timer 1 mode as a timer operation, right? Then second, load registers TLN and THN, that means higher 8 bits and lower 8 bits with initial count value. Right. After this slide we are going to see how to calculate the count value, right? This is one most important one, right? Then start the timer, so that can be done with the help of TRN bit which is present in TCON register. Next, keep monitoring the timer flag, because we know that initially suppose I am there with some initial values of 1 2 3 4, and when we are going to start the timer, right? So these values are goes on incrementing up to FFFFH. And what we have to do, we have to wait until this value is reached up to this maximum value, right? And the moment at which it is going to reach the maximum value, upon reception of next clock pulse, the values get attended or the values get resetted to 0. And for this specific what we call the rollover, okay, or for the overflow, the status of this TF flag is going to change from 0 to 1. So we have to wait until this flag bit is set. Once the flag bit is set, simple stop the timer, then clear this flag, and if required again just load the initial value and continue with the process. Okay, so these are the simple 6 fixed steps that we have to follow when we are dealing with this timer or counter mode, that is a 16-bit timer counter mode configuration for timer, right? Now the most important one, what are the steps which are associated with calculating the count value? Now what is the necessity of count value, right? So just try to get here. Every time when we are talking about the as a timer operation, what we say, for timer operation the internal clock source is used, right? Suppose I want to give some delay, right? Suppose I want to give the 1 millisecond delay in my program. So what we are going to do in 16-bit mode, we know that what is the maximum attendable value? It's a FFFFH. Just try to get this, it's the most important. Many of the students not understood why we are going to calculate the initial count value and all. Here is the answer for that, why to calculate the initial count value. Just try to get a scenario, right? Suppose I am using the timer 0 in mode 1, okay, fine. Timer 0 in mode 1 as a timer. Okay, so I'm using this timer block. I want to generate a delay of 1 millisecond. So what I'm supposed to do, corresponding to 1 millisecond, suppose I'm getting some initial count value as a 1 2 3 4. Say my initial count value is a 1 2 3 4, and as we know that as it is a 16-bit mode, the maximum value that can be attended or that is attended by the timer in mode 1 is a FFFFH. So what will happen? When depending upon the reception of these clock pulses, this count value goes on incrementing by 1. So 12, 35, 36 up to what? FFFFH. So this is a maximum value. So whatever the time or the number of clock cycles or the time required here to start from 1 2 3 4 and reach up to FFFFH, this is nothing but what your 1 millisecond time. Means suppose initially my timer 0 is going to hold this value, then every time this value goes on incrementing by 1 like this, and when it is going to reach to this maximum value, right, and then the rollover occur. The moment at which rollover occur, this is whatever time span is there, this time span is what? Simple the 1 millisecond time span. So what it defines? if I am going to change this count, again this time value will be get changed. So this is my final initial position, this is a final position, and whatever time required for this timer count to travel from initial position to final position, this is nothing but an amount of delay. Simple. If I am going to change this count value, suppose my count value is say like 3 4 1 f, like this, suppose. So this delay will be different. Suppose the count value is f1, then this delay value is again different, and corresponding to this, why this is changing, because this upper limit goes on changing, right? So the initial value is changing. Okay, so this is nothing but what? This is nothing but this count value that we have to calculate. So these are the fixed steps that we have to follow when we are going to configure any timer in mode 1. Now let us discuss the different steps which are used to calculate the count value for 8051 microcontroller. And as usual, we know that the 11.0592 MHz crystal is connected, so we are going to consider the 11.0592 MHz crystal, okay, for the operation, right? So here, first of all, what is the first step? In step 1, whatever the given delay is there, this delay we have to divide by 1.085 microsecond, and this I am going to term as value n. This is my first step. Whatever the amount of delay that need to be introduced, right? So that amount of delay we have to divide by 1.085 microsecond, and whatever the result I am getting, right? Suppose I am going to deal with this. This is x amount of delay, so x divided by 1.085 microsecond, and the amount, suppose I am getting the y here. So this y is nothing but what? I am going to term here as a n. So this is my step number 1. In step 2, as we are dealing with the 16-bit mode, right from 0000 to 65535, right? So all these are total 65536 values. So whatever the value that obtained in step number 1, that is amount n, that we have to subtract from 65536, right? So here whatever the result I am getting, say 65536 minus n, so whatever this result we are getting is what? Simple, your xxy. Okay, so this is my step number 2, and whatever the result that we have obtained in step 2, that is value xxyy, simple convert that into x, and this I am going to term as what? mmnn. And at last, as a last step, just copy the higher bit into th and the lower bit into tn, depending upon which timer you are using. So these are the 4 fixed and constant steps that are useful to count or to calculate the count value that need to be loaded into timer. So what we have to do, first, whatever the amount of delay that need to be introduced into the that program, we have to divide that by 1.085 microsecond. Then this obtained result we are going to subtract from 65536, and the result which I am getting here, this result is there into decimal format, right? So this result we have to subtract from, okay, so this subtraction result, sorry, this is a decimal, this we have to convert into hex format, and whatever hex value we are getting, this hex value we have to load into time. So in this way, simple, the 16-bit timer counter mode configuration is done and your count value is calculated. So let us see this with simple example. So consider an example, okay. Find, what is my example here? Find the count value to be loaded in timer 0 to generate the 5 millisecond delay, right? So I am going to consider here the timer 0 in mode 1, okay, right? So what will be my first step? Just we have said divide the given delay by 1.085 microsecond. So here the amount of delay is 5 milliseconds, so this 5 millisecond divided by 1.085 microsecond. So the obtained result is what? It is 4608, simple, okay, after doing the first step. So here is what? This is the value of n, and this value of n is there into what? Decimal number, okay. Simple, divide given delay by 1.085 microsecond. So here the amount of delay is 5 milliseconds, so 5 milliseconds divided by 1.085 microsecond, I am getting the value as a 4608. Okay. Second step, subtract value obtained in step number n, step 1, that is value of n, from 65536, 536, and this value we are going to term as what? I am going to use the notation for the result as xxyy. Okay, so xxyy is equal to 65536 minus 4608. So the obtained result is what? 60928. So this value is again there into decimal format. Okay, and next step, convert the value obtained in step 2, that is amount of xxyy, that is a subtraction result, into hex. So this number, right, when I am going to convert into hex format, right, I am getting the value as what? EE00, say 60928. This is there into decimal. When I am going to convert this into hex number, okay, that is in a hex format, the result I am getting is what? EE00H. And what is the last step? Load mm into thn and nn into tn. Means now this obtained result I am going to term in this way. This is mm n n. So what we have to do? This I am supposed to load into a higher 8 bit, and this I am supposed to load into lower 8 bit, right? So here, as we are using the timer 0, right? So th0 is now EEH and TL0 is now 00H. So in this way, the timer 0 is going to hold the value EE00H. So in this way, we can calculate the amount of count value that is to be required and need to be loaded into the timer for the operation. Now let us consider one practical example. Assume that 11.0592 MHz crystal is connected to 8051 microcontroller. Write a program to generate a square wave of 2 kHz frequency on P1.5. And for this, what we have to do? We have to use timer 1 in mode 1. Right? So as per the steps, first of all, we have to calculate the amount of count value that need to be loaded into this timer. Right? Now the one thing is clear. What we have to do? Simple. We are supposed to generate a square wave. Right? So here I am there with this square wave. Right? So this square wave possesses a frequency of what? Simple, you are 2 kHz. So now the time, right? So the time required is what now? The t is equal to, here the value of f is what? F is 2 kHz. So because of that, the amount of time, that is total time, is what? 1 upon f, that is nothing but what? 1 upon 2 kHz, right? So after dealing with this, I am getting the 500 microsecond as the total time period, right? So here I am there with what? The total time period. This my total time period is what? It is 500 microsecond. This is the total time period. Okay, let me write it properly. This total time period. This is what? This total time period. Yes, so please consider. This total time period is a 500 microsecond. Now one thing is clear. This is a square wave with a 50% duty cycle. So this amount is 250 microsecond. For 250 microsecond, my pin status should be high, and for again 250 microsecond, the pin status should be low. Right? So high and low. So in this way, the operation is done. Right? So the total, the exact delay that required is what? It's a 250 microsecond. We are getting the 500 microsecond. This is the total time span. Again, as it is a square wave, t is equal to t on plus t off. Okay, and as it is a square wave, so it is 250 plus 250, right? So I have to design the delay routine in a such a way that I have to find out the count value in a such a way that, right? So here simple, my initial count value I am going to say, I suppose it's a xx. Okay, suppose the count value that I am going to say is a xxyy, and as it is a 16-bit mode, we know that the permissible value is a ff. So what basically it indicates? Okay, so what mainly it indicates? Just wait. We have to find out the initial count value in a such a way that, right? This initial count value in a such a way that from here, next what will happen when the next clock pulse is received, it is count value get incremented by 1 by 1 by 1. Okay, so initial count value, so it is get reached up to this final, right? So this total amount of time is nothing but what? Simple, now my 250 microseconds. So this upper count value we have to calculate just now. And how we are going to proceed for that? Here the amount of delay is 250 microseconds. So to calculate the first step, divide the given delay by 1.085 microsecond. So 250 microsecond divided by 1.085 microsecond, the output I am getting is what? 230. Right. So the next, whatever this value of n I am getting, subtract it from 65536. So 65536 minus 230, the obtained value is what? 65306. Okay. Now convert this values there into decimal format. Convert that into hex. So I am getting the result as FF1A. So this FF just load into higher 8 bit. Okay. Sorry, here. Okay. This FF load into higher 8 bit, as we are using here the timer 1. So it is TH1, and this 1A we have to load into the lower 8 bits here. Okay, so this is what TL1. So TL1 is equal to 1AH and TH1 is equal to FFH here, right? So in this way we have calculated the count value. And what is the use of count value here? What it indicates, my initial count value is now FF1AH, and the maximum permissible value is what? Means the low before overflow it's going to reach the FFH. So upon reception of each of this clock pulse, this count value goes on incrementing. So FF1B, then the next will be FF1C, like this, and it is going to reach up to FFFFH. So whatever the amount of time that required to travel from initial value to final value, this time period is nothing but what? The total 250 microseconds. So these are the steps that we have to follow when we are calculating the count. Okay. Now next, this is my program. Right. So as we have to generate this square wave on P1.5, right? So what we did, so first I am going to clear this P1.5. So the status of P1.5 is now low. Okay. Then simple call delay. So in this delay routine, now I am defining this timer activity. Right. So what we did, move tmod comma hash 10h. Right. So we know that the status of tmod gate c/t bar, then m1 m0, okay, and again gate c/t bar m1 and m0. As we are not utilizing the timer 0, whatever the lower 8 bits are there, I am going to keep this as a 0, because in our program what is it is mentioned, we have to use the timer 1 in mode 1, right? And for that, as we are not using timer 0, on this bit should be set to 0, right? We are not utilizing gate, the timer 1 is used as a timer, and for mode 1 the value is a 0 1. Okay, the value is what? 0 1. So the equivalent value is what? 10h, right? So first of all, what I am going to do, move tmod comma hash 10h, right? Okay, so what it indicate, the timer 1 is configured into 16-bit mode, that is nothing but what? Mode 1. Okay, now we have to load the count value. So here the calculated count value is what? FF1AH. So out of that, the 1AH is copied into lower 8 bit and FFH is copied into higher 8 bit. So step 1, just here as discussed, right? What is that? Just load the value, then load the count values, then start the timer. How we are going to start the timer? Right? I am going to make this set bit TR1. So the moment at which, as we are using the timer 1, we have to write here set bit TR1. The moment at which I am going to start the timer, what will happen? This is the initial value 1AFFH, right? So when we start the timer, the count, these values get incremented by 1. So it is now 1B00, then 1B01, 1B02, 1B03, and up to, it is going to reach up to FFFFH, right? And whatever here, this is the time there, right? Start from 1A to FF, this time is nothing but what? The total 250 microsecond time, right? Now we have to wait. Why we have to wait? Because when your overflow occurs, then and then only we can say that total 250 microsecond delay has been provided by program. So from the initial value up to this final value, the status of TF1 flag is 0. Okay, from this initial value to this final value, the TF1 flag is 0. So what we have to do, we have to just wait, let the count value to be get incremented, and when it is going to reach to maximum value, and now after that when the rollover occur, then the TF1 flag is going to change its status from 0 to 1, and the moment at which the status is changed to 1 means the rollover occur, what we are going to do, immediately I am going to stop the timer, and that I am going to do with clear TR1 instruction. So just stop the timer, then clear the TF1 flag and just return or come back to this. Okay, means what, complement this P1.5. So earlier it is low, now this value is what, simple your high value. Okay, so in this way we can generate the required frequency using the timer, right? So let us cross check this with one simple example. Okay, so here what I did, simple, instead of directly going for this clear P1.5, only minor change I did. I am going to set, initially I am going to set this bit. Okay, so as per the step here, this delay routine introduce you, or this delay routine give us an idea about the timer operation. Okay, here it is. This is what my simple timer operation. So what I am going to do, move tmor comma hash 10. So what we did here, the timer 1 is configured into 16-bit mode, and this is nothing but what, mode 1 of operation. Okay, then the lower 8 bit, that is 1A, is loaded into lower 8 bit of timer 1, and FF is loaded into higher 8 bits of timer 1. Then just start the timer, wait for timer flag to set, and once it's set, stop the timer, clear the flag, and again go back to the main routine. Okay, so what we did, complement P1.5. Initially P1.5 is high, now it is set to low. Okay, and this continuous operation is done. Okay, so let us cross check the execution. So let us check the execution. Here I am using this timer 1. So we are here with this timer 1. Not necessarily go with the memory, right? Okay. And the port P1.5. Okay, so let's check the stepwise execution. So initially the P1.5 is set, then a call D. So it will directly jump to this move tmor comma hash 10h, right? So initially the status is 00, means by default the mode 0 has been activated for timer, right? So I am going to execute the first. Just pay attention what it indicates, 0:0 means what, mode 0, and which is that mode, it is a 13-bit timer or counter mode here. Okay, and the timer is working into the timer mode, right? So when the first move tmor comma hash 10 is executed, what will happen, right? The mode 1 is selected, which is nothing but 16-bit timer or counter mode, and the timer 1 is working into the timer operation. Okay, now next, here if you see the TL and TH means the content of timer are now equal to 0. The next step, what is happening here, just the 1A is loaded into lower 8 bit and FF is loaded into higher 8 bits. Okay, and now still the timer is not started, so because of that it shows the status of timer as stop, and just check out here, right? Now the timer is there into a run mode. Okay, so now the content of this are get incremented by 1. Okay, if you see here, so we are here with this. So just pay attention towards this. Now suppose the value that is said to be set final is now FE. Now it is reaches to 00, right? And once it reaches to 00, the TF1 flag, which was earlier 0, now it is gets set. Then it goes to the next step. So stop and go back to the main routine. So in this, right? So in this way I am getting this square wave, okay, on P1.5. Even we can see it. So in this way here, right? At one moment your timer is stopped when the timer is get stopped when the TF bit is set, right? So we can configure the mode 1 of operation for timer. Thank you.